When you have a quantity that has periodic behavior, meaning it's kind of bouncing back and forth between numbers, then we can use a sinusoidal function. That sounds super fancy. It just means sine or cosine to model it. And sine cosine functions, they're waves. They go up and down in a very steady pattern. Now there are the sine and cosine functions, but we're just going to work with the sine model because the cosine can actually be shifted and it can match the sine. And so really any sinusoidal function can be written using a sine. Now there's a lot of different things in this, and so we're going to look at how they all affect the graph of the function. First of all, A is the amplitude of the function. I'm gonna come down here. I'm gonna sketch a graph real quick. So I'm gonna make sure that I've got a straight line. So a sinusoidal function is gonna look something like this. And excuse me for not being perfect, and you'll have to excuse the imperfect drawing, but that's the idea. And there's kind of this line that we're bouncing around, okay? A is the amplitude, and it's the distance from the equilibrium, which is this middle line, to a peak of the wave. And so just to kind of illustrate that, that's from here to here. That right there, that distance is A. Next, we have the period, and actually it uses this number b, but it's 2 pi divided by that b. Now, we won't get into the details of why that is, but the period, just to draw, it's the length from peak to peak. How long does it take to complete a full cycle? Okay, that is 2 pi over b, okay, which is the period. All right, the phase shift. That actually just kind of tells us if this has been moved, left or right. So, for example, if it's over here, we're gonna have a different C. If it's over here, it's gonna be a different C. I'm not gonna again worry about that so much right now. It's not something I'm gonna draw. We're not gonna need to know too much about the phase shift. And finally, we've got the vertical shift of the function, and this is the middle value of that cycle. That's this number. Let's do a different color, shall we? That's this number right here. Okay, that's D, is where the middle of that wave is. Okay, and so if we have a function, we can create or we can figure out lots of different things, like how high does it get, how low does it get, because this A is the same as the distance from the middle down here. That is also A. My picture always doesn't make it look very good, but it is. Okay, so from the middle down and the middle up, those are the same lengths. Okay, so we can, if we just know the equation, we can figure out how high it goes and how low it goes, how far it's stretched out, all that great stuff. Let's go ahead and look at an example. Consider the sinusoidal function. Y equals 3 sine of 6x plus 1 minus 2. We want to know the maximum value of the function. Now I'm going to do a quick picture here, and it's not going to really matter how it relates to this, but I will point a couple things out, okay? This number here is where that middle is. So if this is my axis here, okay, that's my x-axis, not my y-axis. -2 is where the middle of the wave is. Okay, 3 is the amplitude. That's the distance from the middle that I'll be going up and from the middle that I'll be going down. So if I go up 1, 2, 3, that puts me up at 1. So I'm going to have a wave that's coming down. That goes up to 1, and it goes down the same distance. So if I go down 3 from the middle, well, it was at -2. 1, 2, 3 down is down at -5, and that's where my low point's going to be. So that tells me my maximum and my minimum. Okay, in general, my maximum is at D plus A. Okay, whatever that number is, make sure you're adding a number there. So in this case, it's -2 plus 3, which is 1. So the maximum is 1. The minimum value, okay, is d minus a. So that'd be -2 minus 3, which is -5. That's the minimum. Now you do have to be careful because sometimes this this number might be written as a negative, in which case just make sure you force it positive first in order to get the maximum and minimum. And finally, the period of the function. The period is 2 pi over b. Okay, and b is the number right in front of the x. So that's 2 pi over 6. And if we simplify that, we can just 2 over 6 is 1/3. So this is pi over 3. Okay, which is a little bit more than 1. Okay, that means the distance from peak to peak. Okay, oh, that was really ugly. This distance right here is a little bit more than 1. Okay, that's a distance of pi over 3.